Hi, I'm Antoine Simona, and I'm super happy to present you our paper, Unifying Parsing and Tree Structure Models for Generating Sentence Semantic Representations. The paper starts from the strong hypothesis in an NLP that language has recursive structures. And there have been a lot of propositions of neural networks which are tree-shaped and that mimic the compositional effect of language. But obviously, one of the main limitations of such approach is that it not only required raw text as input, but also the structure of the sentence. In this paper, we introduce a tree-based model which learns together the composition function and the structure. Basically, the architecture produces sentence embedding by composing words according to the induced syntactic tree. Moreover, the parser and composition function are explicitly connected and therefore can be learned jointly. There have been a lot of propositions to unify parsing and recursive encoding, and the main advantage of our method is that it can be fully trained using backpropagation, and also it relies on existing and well-known components. We use two types of components. First, a graph-based dependency parser that output a weighted tree structure of the sentence, and then a weighted tree LSTM that uses structures as input to compose words according to the structures. The weights from both the parser and the recursive encoder make the link between them and enable us to train them jointly using only the downstream supervision. We propose several analyses in the paper. First, we evaluate our model on downstream tasks. Here we present the result on the seek-R downstream task, which is dedicated in evaluating the model compositional properties. The dataset consists in sentence pairs, which are annotated for semantic similarity in a 1 to 5 range. For this specific example, we pre-train the parser module on human annotated sentences from the pen tree bank. And then we fine-tune the parser and the tree LSTM jointly using the downstream supervision. We show that our model outperform models that are relying on weaker underlying structures, and we are even close to BERT base, although it was trained on vast corpora. We then perform a second type of analysis, and we study how the initialization of the parser impacts the final downstream performance and the resulting structures. For this experiment, we initialize the parser using various proportions of the pen tree bank. Either we pre-train the parser on the full pen tree bank as before, or only on 100 randomly selected examples. Or we just initialize it randomly and do not use any example from the pen tree bank. In all configurations, we either continue to update the parser when fine-tuning the model on the downstream task, or we just freeze it totally and only update the tree LSTM parameters. We show on the left the results on the seek-R performance, and we show that models that use full annotation outperform those without, and also in a range, we show that updating the parser yields to better results. On the right, we compare parses from several configurations using the unlabeled attachment scores, that is the ratio of common arc between two parses that only differs by the initialization. We show that randomly initialized parser yield to really low UL scores, which shows that there are really few in commons with silver annotation. But using only 100 examples yield to ULs that are really high, which shows that only a few examples from the pen tree bank are sufficient to generate parses that are relevant in terms of comparison with silver linguistically annotated example. Also, in a range, we show that updating the parser on the task yield to a variation of the UL score, and we interpret that the parser is able to adapt itself to the specificity of the task. In conclusion, we evaluated our model in several downstream tasks. We propose other examples in the paper, so we really encourage you to look at these additional examples, and we show in this experiment that we are competitive with a sequential model or with BERT-based upper line. We also corroborate in the second set of analyses that the sole use of downstream supervision is not sufficient to produce parses that are easy to interpret, but only a few parts are sufficient to generate parses that are close to linguistic annotations. Finally, we propose additional experiments in the paper, including a proof of concept using BERT as input for the parser. So thanks a lot.